This SciShow compilation video is brought to you by you. When you buy the SciShow calendar and the SciShow space calendar, that money goes towards the high quality product that you'll get to enjoy all year and the people who made it, who are also the people who made this video. So thank you for supporting SciShow. If you haven't claimed a calendar yet, you can find them for a limited time at complexlycalendars.com. Vampires have filled our spooky stories and nightmares across generations and cultures. They're one of the most pervasive myths out there. And to be that far-reaching, these undead creatures must have some basis in reality. As it turns out, there are several animals on this planet that have vampire-ish tendencies, including us. So here's Michael to explain the science behind the vampire myth.
Vampire stories have been popping up for centuries, and some of them are a lot scarier and less sparkly than others. The most common stories involve dead people walking the earth with pale skin, a fear of sunlight, and a thirst for blood. But that myth might actually have some basis in scientific fact, really. Most cultures have some sort of vampire-like story. In Chinese folklore, for example, there are evil spirits that drain your life away. And in India, there are legends about demons who used to be people, but weren't cremated properly. Mainly, these myths probably came from a deep misunderstanding of how diseases spread. During epidemics like the plague, people were understandably terrified and searching for explanations for the apparent randomness of the illness. But the vampire myth that's caught on in pop culture has very specific symptoms, and scientists believe they might be traced back to actual medical conditions. The first possible connection is a group of disorders called porphyria, which are caused by too much of a molecule in your blood called porphyrin. Your red blood cells mostly contain a massive protein called hemoglobin, which moves oxygen and carbon dioxide around your body. And in the middle of hemoglobin is a ring of carbon, nitrogen, and hydrogen called a porphyrin ring. Normally, enzymes convert porphyrin into another molecule called a heme group, but for someone who suffers from porphyria, their body doesn't have enough of these enzymes, so the porphyrin builds up and causes problems. For one, it makes their skin really sensitive to sunlight, and they get painful rashes and blisters, but only when they go outside. The excess porphyrin also builds up in their teeth and mouth, causing red or brown discoloration. It can even look a bit like they've been drinking blood. Today, porphyria is treatable, but back in the Middle Ages, it wasn't very well understood, so people could have made up all kinds of stories about it. Most kinds of porphyria are also hereditary conditions, so stories could have easily spread about a group of vampires or one vampire who infected their family. Another likely origin for the myth is a condition called pellagra. Pellagra is caused by a dietary deficiency of two things: niacin, also called vitamin B3, and an amino acid called tryptophan. Normally, your body uses niacin to turn food into energy, and even if you aren't getting enough of it in your diet, your body will also create niacin from tryptophan, so everything should still run smoothly. But when you aren't getting enough of either, things go wrong. Around 300 years ago, corn started to replace wheat as the food staple for a lot of Europeans. This was great because it grew really well and it was cheap, but it also wasn't very nutritious. In Mexico, where corn had been farmed for centuries before it came to Europe, the kernels were treated with a mixture of water and the mineral lime before use. That caused a reaction that released all those healthy vitamins, but it wasn't a practice Europeans brought home with them. To make things worse, corn also doesn't contain much tryptophan, so there was nothing for their bodies to convert into niacin. No matter how much corn people ate, they couldn't get the vitamins they needed, so pellagra started popping up all over the place. The symptoms of pellagra actually look pretty similar to porphyria. Patients are sensitive to sunlight and get terrible rashes if they go outside. Sometimes the rashes get so bad that the skin starts to degrade over time, looking pale and papery. Their mouths also turn red and their tongues start to swell. People are often left with imprints of their teeth in their tongues, which could have started the idea that vampires have large canine teeth. Pellagra can also cause neurons to degenerate in the brain, which can lead to severe mental illness and insomnia. Add in a sunlight allergy, and that might explain why vampires in the stories don't sleep at night. Now, pellagra and porphyria might explain some symptoms, but the whole Walking Dead thing might have come from something totally different. Some think it comes from a neurological condition called catalepsy. Like epilepsy, it affects signaling in the central nervous system, but instead of muscle spasms, the person's muscles seize completely and everything seems to shut down. They can't move at all, and their heart and respiration rates slow down until it looks like they're actually dead. And since doctors back in the day didn't have access to sensitive machines to measure whether someone was alive, they often thought someone experiencing a cataleptic seizure had died. And what did they do with dead people? They buried them. Like you can imagine, if you saw some guy climb out of his coffin, it'd be super hard for him to convince you that he was actually alive and not a blood-sucking vampire. All three of these conditions still exist, but thankfully, they're much more treatable or avoidable now. And at the end of the day, we know that they're definitely not anything to be afraid of.
Alright, so Dracula might not be real, but a lot of his behaviors can be explained by real phenomena. You may even be familiar with some of them through your own lived experiences. For example, here's one reason you might need to live like a vampire.
We all know that the sun can be dangerous. The UV radiation that beams down on you at the beach can damage your DNA, giving you painful burns and eventually possibly cancer. And that should be reason enough to wear sunscreen, but for some people sunlight means hives or itchy rashes. That's right, you can be allergic to the sun. If you have a condition called solar urticaria, big itchy welts develop within minutes of sun exposure. Now these hives die down within a day, but as you can imagine, this disease seriously puts a damper on going outdoors. Scientists don't fully understand why this happens, but they think it's pretty similar to how your immune system might overreact to peanuts if you have a food allergy, or to pollen if you have seasonal allergies. In those cases, the immune system sees allergens like peanuts or pollen proteins as foreign invaders and arms special cells with antibodies that recognize them. So when those proteins pop up again, those immune cells spring into action and release a bunch of histamine. Histamine is a compound that spurs blood vessels to become leaky and muscles to contract, which helps more immune cells flood in and fight off any junk, but it also causes the telltale symptoms of an allergic reaction, like red blotchiness or swelling. In solar urticaria, that same process seems to happen, but the molecule that's causing the immune system freakout is a mystery. The leading theory is that some people have light-absorbing molecules in their skin that transform into allergens when the right wavelength hits them. In severe cases, people can even develop welts from light bulbs, or when they're wearing thin clothing outdoors, or even go into anaphylaxis. The good news is that this sun allergy is extremely rare. Of all the people who get hives, only about 0.5% of them do because of the sun. There's a similar condition that affects as many as 10 to 20% of some human populations called polymorphous light eruption, or PMLE. It's also a sun-triggered rash, but as the name polymorphous suggests, it can be a bit of everything, from itchy, fluid-filled blisters to simple raised bumps or red patches. Instead of showing up almost immediately like solar urticaria, it can take hours or even days, and it sticks around for a while too. How the immune system goes overboard in this case is even less well understood. But because of the delayed timing, it's thought to be similar to a poison ivy reaction, which activates immune cells called helper and killer T cells and causes inflammation. Except instead of an oily sap, the trigger in PMLE is another mysterious light-sensitive molecule. Fortunately, PMLE doesn't cause scarring, and with repeated exposure to the sun over time, the rash outbreaks often improve. So while there may not be sunlight-fearing vampires roaming the planet, there are some people who need to live a little bit like them.
So a sun allergy might be where the avoidance of sunlight part of the myth came from. And the moon-themed SciShow space calendar is especially vampire-friendly. Or if you're more into the count, you might be drawn towards the pie-themed SciShow calendar that showcases a digit for each month. You don't want to get caught letting social media tell you that spooky season has already arrived. So stay on top of it with a SciShow calendar, which you can grab at complexlycalendars.com. Now the spooky part about vampires isn't their sun avoidance so much as their thirst for blood. And nature, of course, provides some inspiration for that in the vampire bat.
Vampires. They're in all kinds of spooky stories and certain young adult fantasy romance novels. There may not be undead blood-sucking humans walking around, but blood-drinking mammals do exist in the form of vampire bats. Surviving on a diet of only blood, also known as hematophagy, isn't easy, and vampire bats are one of the few mammals that have evolved a thirst for blood. Along the way, they also developed some useful techniques to help them survive. To be clear, vampire bats don't exactly suck blood. Instead, they drink blood using the physics of capillary action, where liquid can move through a narrow tube or cylindrical space, often against the downward force of gravity. Vampire bats have special grooves on their tongues, which, along with their lower lip and incisors, can create a tube-like shape that easily wicks up the liquid. They do make a lapping motion with their tongue, which helps speed up the process, but it isn't necessary for capillary action to work. Another thing that helps keep the blood flowing is the bat's saliva. Vampire bat saliva contains a protein called desmodoplase, which researchers nicknamed Draculin. It acts as an anticoagulant to stop blood from clotting. Researchers have actually isolated this protein from vampire bat saliva in the hopes of turning it into an anti-stroke medication. Since it helps stop blood from clotting, it might also be good at preventing blood clots in human brains. So when a vampire bat bites into a juicy blood vessel, the proteins in the saliva keep the animal's blood free-flowing for a big meal. And vampire bats need a big meal every time they feed. Blood isn't a very rich food source. It's mostly made up of water with small amounts of protein, sugar, and trace minerals. It's completely lacking in fat, and animals tend to need fat, which is a major type of energy storage in a balanced diet. So vampire bats need to drink about half their weight in blood every day to get enough nutrients to keep their metabolism running smoothly. Since that means they're taking in a lot of water, their digestive and excretory systems quickly filter out water and leave the proteins, sugars, and minerals to be digested. In fact, vampire bats will often start urinating even before they've finished feeding just to keep things flowing. Finding food takes some special skills though. Like other bats, vampires use echolocation to fly around and look for prey. They also have a keen sense of smell and decent eyesight. But the wrinkly faces of vampire bats have specialized nerve fibers loaded with proteins that allow them to detect the infrared radiation given off by warm-blooded animals. Once they find something to eat, the 3 known species of vampire bats all have unique feeding behaviors. Common vampire bats feed only on blood from mammals, and they prefer livestock. So these bats evolved ways to quickly maneuver on the ground and reach their prey more easily. They have strong hind leg muscles and elongated thumbs at the tips of their wings, which they use to jump around. They're agile enough to escape from ground predators. Hairy-legged vampire bats, on the other hand, feed exclusively on bird blood and hunt from the treetops. They jump onto unsuspecting birds from above and usually try to bite the bird in the cloaca, the multi-purpose exit point for a bird's digestive and urinary tracts, and also the place where it keeps its reproductive organs. And for some reason, the birds tend to not like this very much. So to stop the bird from fighting back or knocking it off, the hairy-legged vampire bat uses the big bony spurs on its ankles to help it hang upside down and latch onto its prey. White-winged vampire bats feed on both mammals and birds, but they evolved a few tricks to help them feed on chickens. Sometimes, the bat lands on the chicken's back, so the chicken thinks the bat is really a mounting rooster. So the chicken just crouches down, giving the bat access to its neck for feeding. Other times, the white-winged vampire sneaks up from underneath the chicken and nuzzles against the brood patch, a featherless spot of skin normally used to keep chicks warm. The chicken thinks it's being nuzzled by a baby chick and lets the vampire latch on and start drinking blood. With all of these complicated feeding techniques, you'd think vampire bats would have no trouble finding a meal, but sometimes they don't get enough. Luckily for the bats that don't find enough food, vampire bats live in large colonies that contain thousands of bats, and they take care of each other using a behavior called reciprocal altruism. Often, one bat will sacrifice their own needs for another, with the assumption that they'll be helped in return in the future. The main way they do this is very appetizing. They regurgitate blood to share with bats that weren't able to get a meal. Bats who have shared blood meals in the past get larger donated meals in return, compared to more selfish bats. So yes, like Dracula, vampire bats are skilled blood-drinking hunters, but they also have to be extra nice to each other to help their colony survive.
It's a bit of a relief to know that real-life vampires have to be nice to each other. Since it's so hard to survive on just blood, these bats help each other out. But there are other animals that live off of blood that don't do it the altruistic way, like ticks. And you can't keep them away from you as easily as putting on your dog's flea and tick collar. And here's why.
Fleas and ticks have been a nuisance since time immemorial. Fleas can make you all itchy, and ticks, they can carry the bacterium that causes Lyme disease, which can cause fevers and a rash even if it's quickly treated. Especially if you like spending time outdoors, it can be hard to avoid these parasites. And it doesn't help that the animals we keep as pets make good hosts to these bloodsuckers. The good news is there are some tick and flea repellents available for humans. But then again, they just aren't as convenient or long-lasting as the medicines you give your dog or cat. So some days, it seems like life would be easier if you could just slap on your animal's tick or flea collar and hike into the woods worry-free. But you definitely shouldn't. Here's why. Flea and tick collars work by slowly releasing chemicals like deltamethrin or pyriproxyfen. They dissolve in the natural oils of a pet's fur and can repel and or kill pests. Many do this by preventing their targets from growing or by totally shutting down their nervous systems. This is the same method used by those topical gels you might put on your dog's back once a month, and it's generally pretty effective. But there are reasons you should never use these things on yourself. When you apply this kind of treatment to your pet, the medicine is absorbed into the animal's oil glands and then is slowly released into their fur from there. This means the toxins will never be present in large quantities, so they don't pose a significant danger. But if you try to wear one of those collars or slather on some gel, for one, they can seriously irritate your skin and cause feelings of tingling or burning. But also, unlike cats and dogs, you sweat basically everywhere. And for flea collars, that's a big deal, because that sweat can cause a bunch of chemicals to come out of the collar at once. So not only would you be absorbing a bunch of neurotoxins, but you'd also be using up a huge portion of the treatment in one go, which means you'd have much less protection against those parasites. Of course, pets have other pest repellent options too, like oral medications, which work roughly the same way, but you really shouldn't try those either. That's because these medications can also contain neurotoxins. Pets can usually handle small doses of them though, and they're helpful because the treatments can last a while once the chemicals are secreted into their fur. Humans are another story. For one, it's not clear if an oral pesticide like this would even work for for us. But even if it did, we don't have fur and we bathe a lot more, so those chemicals wouldn't stick around for long. So even though flea and tick treatments for pets are convenient and long-lasting, they're not worth trying on ourselves. If you want to fight off those parasites, you're better off sticking with treatments made for humans, like permethrin. Although it is a nerve agent, it's considered safe as long as you don't ingest it. Normally, it's just applied to clothes. It might not last as long as a collar, and it might not be as powerful as what your dog takes, but it will keep you safe. And that's what matters. Oh, and on a small note, there's a reason dogs and cats have different flea and tick medications. Dog treatments are strong enough to be dangerous for cats, so make sure your animals are only getting the treatments aimed at them, too.
Okay, so if tick collars are out of the question, what about building up an immunity to blood-sucking bites? Believe it or not, researchers have looked into that, and Hank can tell us what they found.
Mosquitoes are arguably the worst thing about the outdoors. And if you're the kind of person who seems to be eaten alive every time you step outside, you might have wondered if there's some way you could become immune to their bites. Well, I have some good news. You probably can, because mosquito bites are just a kind of allergic reaction. But like any allergy, the only way to become desensitized is with repeated exposure. And I'm not talking about a few bites, I'm talking about thousands of them over months. When a mosquito bites, she injects you with a chemical cocktail that helps numb the area and keeps your delicious blood flowing. The chemicals themselves don't cause the redness, swelling, or itching, though. Your immune system's overreaction to them does, which is why mosquito bites are considered a kind of mild allergic reaction. Your immune system learns to recognize these proteins as foreign, and it primes specialized cells so that next time you're bitten, your body can launch a rapid immune attack. This is what's known as sensitization. Specifically, mosquito proteins tend to activate the production of two kinds of immune weapons, IgE and IgG antibodies. When these antibodies bind to mosquito proteins, they ramp up the release of the molecule histamine, and ultimately that causes those wonderful itchy bumps. These antibodies can also cause much worse allergic symptoms, though, including full-on anaphylaxis. Exactly why severe reactions happen in some people and not others is something doctors are still trying to figure out. But what we do know is that for the most part, if you can become sensitized to something, you can also become desensitized to it. The trick is to induce your allergic response so frequently that you end up convincing your body that reacting is a waste of energy. That's the basic principle behind allergy shots, also called specific immunotherapy. Doctors have developed standard protocols for allergens like pet dander and pollen, but we know this same idea works with mosquito bites too. For example, the older you are and the longer you live in the same place, the less your reaction to bites from local mosquito species tends to be. But given that, you might wonder why, since you get bitten all the time, you haven't become totally desensitized yet. Well, that's because even if you get bitten a lot, it's probably not enough. If your goal is basically no reaction at all, that takes a lot of bites, like so many. In a prospective study from 1998, researchers took a healthy 23-year-old man and an unlucky rabbit and exposed them to a species of mosquito neither had been bitten by before. As expected, since it was their first encounter with that insect's unique blend of allergens, neither reacted much at first. Their bodies hadn't yet learned to recognize these proteins as foreign, so they weren't sensitized. But then, the pair regularly received between 100 and 150 mosquito bites every 2 weeks for the person and weekly for the bunny. Over the first several weeks, the bite reactions became larger and more uncomfortable. But these brave mammals kept at it. And after 20 weeks of this, the skin reactions noticeably declined. By week 26 or so, both the man and the rabbit were basically reaction-free. That sounds awesome, but if you do the math, it took between 1,000 and 2,000 bites over half a year for the man to get to that point. That's just way more than anyone normally gets in a summer. Of course, since the guy in the study was just one guy, there could be variation between people and how many bites are needed or how long the bite regimen has to go on for. It's also unclear how long this desensitization lasts without maintenance doses of the allergens. But if nothing else, we do know that long-term desensitization is possible because this one guy isn't the only person to become tolerant to bites. Biologists that raise large colonies of mosquitoes for research often feed them with their own blood, sometimes receiving hundreds of bites at a time without reacting at all. And studies suggest somewhere between 10 and 30% of people are just naturally tolerant to the bites from their local mosquitoes. So you probably can make yourself essentially immune to these bloodsuckers if you are willing to be bitten frequently for a long time. We are not recommending that you do that We are not doctors, and this is definitely the kind of thing that you should talk to an allergist about, especially if you're someone who has more severe reactions to mosquitoes. Besides, it might not be too long before your allergist can help you get rid of those welts without thousands of bites. Specific immunotherapy for mosquito bites has been tested, and clinical trials have found it to be quite effective. But also, there are some reasons you might not want to be completely unaware you're getting bitten. Mosquitoes vector diseases, including a lot of really nasty ones, so really, you want to avoid bites whenever possible. Having those bites show up and annoy you can serve as a warning that your anti-mosquito efforts aren't effective. So maybe some itchy bumps every summer is a small price to pay to keep you vigilant against the diseases mosquitoes transmit. And you can always stock up on citronella and DEET instead.
Those research participants still needed to endure a lot of bites. So at least for now, the vampires of our world might have the upper hand. But if we spent as much time thinking about blood as they did, maybe we would have the edge on them. If you want to hear more about that topic, you can listen to the SciShow Tangents episode where they babble on about blood.